Can you please take your seats? Thank you. Good evening, Your Excellencies, distinguished members of the Academy, distinguished members of the Board of Trustees of the Cyprus Institute, Professor Karageorgis, dear colleagues, ladies and gentlemen. It is a great pleasure to welcome you today to this public lecture and panel discussion organized jointly by the Cyprus Academy of Science, Letters and Arts and the Cyprus Institute. We are gathered on the occasion of the publication of the report of the Task Force on Marine Environment and Resources and the EAP workshop to address the critical subject climate change and the marine environment, global and regional challenges. To formally open our session, it is my distinct pleasure to invite to the podium Professor Stavros Malas, President of the Cyprus Institute, for his welcome address.
Thank you, Eleni. Good evening, everybody. Welcome to the Cyprus Institute on this milestone occasion. I'll adopt the protocol, but I'd like to, in particular, welcome our distinguished speakers and Professor Norton, Professor Avarham. Warmest congratulations for your recent distinction. I believe Kostas will talk about it, but this is a very important and an outstanding distinction that you have received recently. Now, as you know, the Cyprus Institute has associated itself with what we all call the Climate Change Initiative, which was launched back in 2019, yes, for 3 years. And the outcome of that exercise is what you see on that table, in addition to a few other reports. But there was one missing, because it was important, and that is on marine environment and ecosystem, and is much bigger. So it is the last one, but the first one of a renewed edition. Now, in all serious countries and in all serious institutions, we talk about climate change. But unfortunately, climate change has been a politically challenged idea these days in the 21st century. I was recently in the United States, and I was listening to an advisor of Professor, I keep calling him Professor, I don't know why, President Trump in another speech the other day. So I don't know why I have in mind. And they said the United States is pushing hard to increase energy production using fossil fuels. It doesn't matter what it does to the environment. You know, they are the biggest polluters. And they want to increase the power production from 2% to 15% precisely to power data centers, supercomputers, because they said, and they did express it, we want to control the world through artificial intelligence. And to do that, we need powerful machines, and to do that, we need energy, and to produce energy, we will burn fossil fuel. I mean, they were thinking about nuclear, but I don't think they're there yet. So we have a serious challenge to try and change that course, not us, but collectively scientists, to change that course of action and really magnify the problem. And the Cyprus Institute has been trying to do this because this region, this part of the world, is going to be hit badly, worse than anybody other region. So we have been working, Kostas, my predecessor, has been working with tens of scientists to really put this report together, and we'll continue this effort, and hopefully we'll make it also one of the flagship initiatives of the presidency of the country of the European Council. So the challenge is to magnify it also to the public, the problem. So today we're going to hear about what will happen to sea level. Now, I'm told that when ice melts in the north, sea level goes down, but sea level goes up in the Mediterranean region. So we're going to hear a very serious challenge for the Mediterranean region, which is going to lead into a serious ecological problem. Now, the Middle East is a region which, if you superimpose the socio-economic challenges of that region, on top of the climate change changes, we call it a hotspot of climate change, then this is a very disruptive environment for politicians, for scientists, in particularly to put together a strategy for adaptation. We're not going to change the world by mitigating measures in this region, but we can definitely do something about this region in terms of adaptation. So adaptation will affect, and measures will affect this country. We have one of the lowest per capita in water in Europe. So we have a serious problem. So we have to take very serious action in our own country to be able to cope with a changing environment and changing climate. So with that, let me again welcome you to this monumental occasion for the Climate Change Initiative. And I'd like Kostas to lead you through, I believe, with the rest of the program. Thank you very much.
Thank you, Professor Malas. It is now my honor to call upon Professor Kostas Papanikolaou to introduce our distinguished keynote speaker and the panelists. Professor Papanikolaou will be speaking both on behalf of the Cyprus Academy of Sciences and as the principal investigator of the relevant IAP Cyprus Academy project, but also as the scientific director of the MSCCI project, under which the marine environment and resources has been developed. He will introduce the keynote address by Professor Karageorgis and the panelists, Dr. Mike Norton and Professor Ben Avarham. Thank you.
Excellencies, colleagues, friends, it's a real pleasure tonight to have this lecture. We're celebrating, in the broader sense, two events. The first event, organized by the Cyprus Academy of Sciences, Letters and Arts, is the commencement of the first workshop on the Inter-Academy panel project named Threats to the Mediterranean Marine Ecosystem in a Warming World. And this is a very important project in collaboration with the European Academy Science Advisory Council, the EASAC, and the Network of African Science Academies, NASAC. This is a highly competitive project that we got, a very prestigious one, and this is the first ever grant to our new academy. So it competes in the international fora. This is the world's academies, and successfully. So it's a distinction that is big for the academy and for Cyprus as well. The outstanding profiles of the 25 scientists that will be participating in this workshop speak volumes about the quality and the prestige that this meta-study will carry. On this occasion, I would like to relay the important greetings and regrets of the President of the Academy, Professor Ioannides. Unfortunately, right now, the Academy has a meeting, which I'm missing, but planning anyway from many months now, so we ended up having two events, so he regrets that he cannot be with us tonight. He's presiding on the meeting of the Academy. The second occasion that we're celebrating is already mentioned by Stavros, is the release of the very extensive, very thorough volume of the Task Force on Marine Environment and Resources, just hot off the press. A team led by the speaker of tonight, Dr. Karageorgis, and as Stavros said, completes the 13 volumes that were produced under the study by more than 250 scientists from the region, monumental work, and now it's entering the phase of where the implications of this are going to be translated into the regional action plan. So go from identifying the problems to identifying the solutions, especially vis-a-vis adaptation. This huge endeavor from Cyprus, now from the beginning under the guidance and ownership of the Cyprus Republic, the president, has taken a renewed intensity, as it's already flagged by the presidency, the president himself, as one of the main thrusts of the EU presidency assumed by Cyprus for the next 6 months. So, without much further ado, because you're here to hear the talk, not me, let me introduce the speaker and the panelists. Our keynote speaker is Dr. Aristomenis Karageorgis, Director and President of the Board of the Hellenic Center for Marine Research, Elkefe in Greek, the most prominent research center about sea research in Greece, and one of the principal ones in the Mediterranean, indeed. Aris is a veteran oceanographer with more than 3 decades of experience. He has made contributions in marine sedimentology, geochemistry, and marine optics, and has over 100 peer-reviewed publications highly regarded in the world. He serves on Greece's national focal point to UNESCO, on the Intergovernmental Oceanographic Commission, and is coordinator also of our Marine Task Force. I can go on and on, but I have to introduce the other and cut it short. Joining our discussion after we'll have a panel, is Dr. Mike Norton, former director of the environmental program at the European Academy Science Advisory Council, EASAC. As most of you know, this is perhaps the most prestigious think tank of Europe. We direct, I see Commissioner Vassiliou notes, because she has been probably receiving advice from them. And Mike combines strong scientific credentials and background, a physical chemist himself, who has served on various UK prominent positions in the Natural Environmental Research Council, the Department of Environment, Food and Rural Affairs, etc., and in academia. But over a decade of service at EASAC, he led the authoring of and coordination, informing them, the influential reports on many topics, on climate change, biodiversity, environmental health, etc. And he played a pivotal role in helping EASAC emerge, as I said, one of the most persuasive voices of evidence-based environmental action. Finally, but not least, Professor Zvi Ben Avarham of the Israeli Academy of Sciences and Humanities, Tel Aviv University, Mercy, and I can go on about another 15. Most prominent of world importance activities. He's a world leader in marine geophysics and tectonics, and serves, as I said, among others, as president of the Mediterranean Experts on Climate Change and Environmental Change position. His pioneering research has transformed our understanding of the structure and evolution of the Mediterranean, especially the Eastern Mediterranean basin. But what speaks volumes is not what I say now, is already, Professor Malas alluded to it. Just a few days ago, he was awarded the 2025 Maurice Owen Medal of the American Geophysical Union. American Geophysical Union is understatement. The American Geophysical Union, as those of us know, is a union that has 62,000 scientists participating from over 137 countries. It's the highest honor in the field. Congratulations, Vi. We're really proud to be associated with you. So, together, our speaker and panelists will bring their deep expertise and perspectives on scientific, technical, and policy-oriented issues. Now we'll move to the real, the reason you are here, to hear the presentation by Aris for the next 30 minutes. Then we'll have a 15 to 20-minute panel discussion, and then we'll open the discussion to the public. Ari, please, the podium is yours. Thank you.
So, good evening, Mr. President, Your Excellencies, ladies and gentlemen, dear friends. I'm very happy and very proud to be here with you. And it is a great honor to be a member of this panel and giving me the opportunity to present an overview of the climate change in the Mediterranean. After the publication of the report, actually, I'm not going to talk to you about the report per se. This is something to be presented tomorrow at the more, let's say, open event. Today, I'm going to give you a talk based on my, let's say, own understanding of what is going on in our neighborhood, the Mediterranean. And I hope we will have a lively discussion and then a nice workshop over the next couple of days. Any clear way to go forward? Susanna? We have to change. All right. Excellent. Thank you very much. So I have given the title, A Portrait of the Mediterranean Under Climate Change. We're going to talk about science, impacts, and potential solutions. And all this is under the workshop that has already been mentioned on threats to the Mediterranean marine ecosystems in a warming world. The first chapter of the presentation is the fundamentals of climate change. I'm more sure that you are familiar with the subject, but a repetition is not bad in any case. So let's start with what is considered to be current knowledge and everybody talks about. We have an elevated concentration of CO2 in the atmosphere, which, according to the current records in the last decades and since the end of the 18th century, has increased by 50% from the very stable, let's say, level of 278 ppm to more than 400. This is common knowledge nowadays. What is interesting to see in the left-hand side of the panel is how we measure CO2 in different parts of the world. The continuous line, the graph, which is starting more than 20 years ago, has been captured in the mountain of Hawaii, Mauna Loa, and shows clearly that there is an upward trend to CO2 elevation. The last part of the graph, which is the red dots, is coming from a climatological station in northern Crete named Finokaya, where we have established data for the last couple of decades. And you can see that clearly the trend is the same, which means that the phenomenon is global, and there's no doubt if we measure the CO2 concentration in Crete or in Hawaii, we're going to get the same results. A lot of people argue that CO2 concentration is not, let's say, connected to human-derived activities. It might be a natural variability, but here we have the record of CO2 concentration in the atmosphere in the last 10,000 years. Apart from this part of the graph, which is actual measurements, the scientists have managed to capture CO2 concentrations in air bubbles within ice cores, And this shows very clearly that since 10,000 years ago, there has been quite a stable level of CO2 concentration, which abruptly has elevated in the last couple of 100 years. But even if we move further back to the future, this is a slide that I have borrowed from my colleague Nikos Michalopoulos. I don't know if he's here around. Thank you, Nikos. This is 800,000 years of carbon dioxide in the atmosphere of the planet in concert with the elevation and the variability of temperature. You see that in the late Pleistocene times, we have quite a variability, and these ups and downs have to do with the glacial and interglacial cycles. But here you can see that really the concentration of CO2 in the atmosphere has gone very high. I think that the analog of the CO2 concentration that we have nowadays has to be recorded previously, the last time during Middle Pleistocene, which is something like 4 million years ago. And if we go further back to the past, a value of 1,000 ppm of CO2 in the atmosphere has been recorded 55 million years ago. Of course, the planet survived and life evolved. What is extremely different in those, let's say, pivotal times of CO2 elevated concentrations in the atmosphere is the pace. It took several tens and thousands of years for the CO2 to increase in the archeal times. Nowadays, the pace is extremely fast, and this, I think, it's no argue about that anymore, at least not within the scientific community that we have today here with us. It has to do with human-derived emissions. So the emissions are coming from a few countries, like China, like the United States, like India, like Russia, and of course the European countries. It's something that we cannot avoid, and as the President said earlier, the United States are planning even bigger consumption of fossil fuels, which is frightening. If we go closer to our neighborhood, we see that Europe has done a considerable effort to reduce the emissions. As you can see, we are going down in the last 30, 40 years. But on the other side, in the neighboring Middle East, the trend is upwards, which means that at the end, we are doing nothing. If we connect the CO2 concentration increase with the greenhouse effect, we get the increase of temperature. It's a very simple phenomenon. We know about that since the school times. If we make an analysis of the pre-industrial times until the current day and take as a level, let's say, of comparison, this green line over here, which is the pre-industrial era, we can see that in the last decade, 2011 to 2020, we have an apparent increase in temperature by 1.1 degrees. This is what we commonly call temperature anomaly. The IPCC, the Intergovernmental Panel on Climate Change, has stated very clearly for the non-believers that global warming is established and human influence on the climate is unequivocal. So some countries took the initiative to make some big effort to reduce the problem, and this is how the Paris Agreement came up in December 2015, and there were a set of thresholds to be maintained. The first one is to maintain the temperature of the planet below an increase of 1.5 degrees, and a second threshold was 2 degrees. But as you can see from this analysis of IPCC, in just 4 years from now, we will be reaching the 1.5 threshold, and probably we will exceed it, and who knows what's going to happen next. The whole world has warmed. The Berkeley Earth Institution says that it has warmed by 1.3 degrees. So I took the liberty to look about Cyprus. Cyprus, according to the analysis, has already increased by 2 degrees. Okay? So you are 0.5 degrees above the global average. And the projection for the future, the end of the century, is plus 3.5 degrees. This is really alarming, and these are the scenarios. We're going to talk about that later, what we are going to do in the future according to the measures to be taken. Now let's jump into my territory, which is the marine environment and the ocean. I have used this nice projection of the Earth to show what we have learned at school. Everybody knows that 71% of the Earth's surface is water, but in this graph, I don't know, it looks spectacular to me. It's really a lot of water over there. And the Mediterranean is just a small pot over here with a great sensitivity, as we're going to show, and very much of interest because we live in it. So what happens to the ocean? The ocean takes up the heat, okay? It acts as a heat sink. It takes more than 90% of the extra heat produced by the greenhouse emissions over the years. And this has warmed up this package of water, which is the upper 2,000 meters that have warmed up much more. On the other hand, the land just absorbs 6 to 7% of the heat, which means that the ocean is taking the burden. At the same time, the ocean absorbs the extra CO2. We have estimates by global models that 26% of CO2 has been dissolved in seawater, and then it forms carbonic acid, as we know, and increases ocean acidity, and it attacks all calciferous organisms in the water column and the seabed. Now, I have set the key consequences of climate change on the ocean. The first one is the most apparent, ocean warming. Okay, we have warmed up the ocean by the excess heat, and this has direct consequences: coral bleaching, species migration, sea level rise, deoxygenation, and more. We talked already about ocean acidification, which has as a consequence the cell dissolution and disruption of ecosystem mechanisms. The other one has to do with temperature rise again, and it has to do with the thermal expansion of seawater, which results in sea level rise, and of course it attacks the coastal habitats where we have losses, loss of coral reefs, and also the very shallow islands. Another threat is the changes in marine currents and stratification. It has to do with a combination of factors, temperature and salinity changes that might disrupt the current circulation in the global ocean, which is a global catastrophe, but it might happen, and it appears there are some relationship with AMOC, the Atlantic Meridional Overturning changes. The loss of polar sea ice is a direct effect. The President also addressed that we have a loss of habitat, we have an increase of albedo, and let's say amplification of the greenhouse effect and disruption of food webs, and of course elevation of sea level. And of course, we have experienced in the last couple of years severe droughts, severe floods, hurricanes. When I was a young scientist, there was no word in the vocabulary like Medicaine. Okay, now we are talking about Medicaine. So things have changed seriously, and the consequences are now not only to the biotic world, but human itself, where we have catastrophes and casualties. All this together, we can say very briefly that we have a disruption and reduction of biodiversity, and also a threat to our food chain and the global fisheries. These are major consequences. So let's go to the next step and try to look into the Mediterranean and see what is going in there, and try to resolve what are the major status and trends of key parameters. The oceanographers call the Mediterranean Sea a miniature ocean, and this is because it is a semi-enclosed marine basin which have a considerable depth. Don't forget that a little bit offshore Peloponnese, the water depth is more than 5 kilometers, which is extreme compared to, let's say, the extent of the basin. It's very sensitive to exchanges because it has only the Gibraltar Strait to the west and the artificial Suez Canal to the east to communicate and exchange water. And it is often called an evaporation basin because evaporation is exceeding the precipitation, what is coming from the atmosphere in terms of rainfall and river inflows. What is also important to know about the Mediterranean, of course, you all know its extremely complicated morphology, which is, at least to the eastern part, the result of geological processes and actually the subduction of the African plate under the Aegean, which creates this very deep sector of 4,000 meters, an island arc and then a volcanic arc, which are unique systems in the whole Mediterranean, one of the most beautiful in the world. So we have a great complexity and great biodiversity. Thankfully, in the last 30 or 40 years, we have the services of Copernicus, the European service, that provides valid reports of the parameters that we measured for the ocean for many years by satellite methods. I took some highlights of the recent reports just to show that we have very hard evidence of what is going on and what numbers. So, with respect to SST, sea surface temperature, we have an increase of 0.4 degrees per decade, which is huge. We have stronger warming, even stronger warming, 0.6 degrees in the Aegean, in the Levantine Sea that we are now, and the Adriatic. We have extremely long-lasting marine heat waves in 2022 and 2023, with temperatures rising up more than 4 degrees from the average. We have some incidents in Italy, very alarming. The Atlantic blue crabs, which is an alien species, overpopulated and created clam production to collapse almost 100%. And also in Sicily, this beautiful animal here, which is named bearded fireworm, threatened biodiversity, human health, and negatively impacted the economy of fisheries. If we go a little bit further back, last year, we had the presentation of sea level average, which is plus 2.5 millimeters per year for the last 30 years. Of course, increase of the ocean heat content, and record-breaking temperature, 29.2 degrees Celsius in the Balearic Islands. This is extremely unique. And usually those kind of temperatures occur in our neighborhood, in Rhodes Island, around Cyprus, but not in the Balearic Islands. As such, we have a rare phytoplankton bloom southeast of Crete in March 2022. For those of you who don't know, the Eastern Mediterranean, and in particular the Levantine Sea, are very, very oligotrophic. We hardly see chlorophyll concentrations above 0.2, 0.3 micrograms per gram, or what is the unit here, microgram per cubic meter. And here we have a spike which is above 0.8. This is very, very awkward. And of course, something that is very rare but very catastrophic is the Daniel storm in September 2023, the deadliest medicane in our history. In Greece, in central Greece, we had rainfall more than 900 millimeters and a flooded area of a couple of hundred square kilometers. But in Libya, in the city of Derna, we had casualties that exceeded 11,000, which is, I don't know, it's really sad that all this has happened from the passage of a hurricane. Also, we have recorded increased wave heights in the southern Mediterranean, and another event that appears to be also elevating is the frequency of marine heat waves. And if you see this timeline here from 1985 to 2016, there is an apparent increase of marine heat waves which have more or less unknown consequences to the marine environment and its life, and this is something under investigation from the scientists. I'm going to look through a number of key parameters and give you some figures. This is the average sea surface temperature anomaly for the global ocean for the last 30 years, analysis of Copernicus always. Apparently, you can see that there is an elevating trend, there's no doubt about that. And the pace is 0.015 degrees Celsius per year. This is the unit that they use here. This is the global ocean. If we go to the Mediterranean, apparently there are some differences, but what is important is that the increase is 0.04, which is almost 2.5 times larger than the global ocean. So what is happening in the global ocean is amplified in the Mediterranean, at least here with respect to the increase of sea surface temperature. We have a system in the Hellenic Center for Marine Research that measures temperature in situ. All the data that we have seen from Copernicus, including this long time series over here, is coming from satellites. And some people might argue, okay, we are not certain that satellites measure correctly and so forth. So this part of the graph over here, for Pylos and the Cretan Sea, is thermometers placed in the sea water and maintained for 20 years. You can see that there is a complete overlap that leaves no doubt that whatever Copernicus measures from space is the same that what we measure on Earth and in particular into the sea water. So there's no doubt that SST delivered by Copernicus is valid and we have to take it seriously. If we look at the spatial, let's say, distribution of temperature anomaly, it is clear again that we have an increasing trend from west to east, which means, my friends, that our neighborhood is the most heavily impacted. The Levantine Sea and the Aegean Sea show the highest degree of elevation in terms of sea surface temperature. What is happening in the Mediterranean is not unique. If you look in this graph, you will see that the change in degrees Celsius per decade is highest in the Black Sea, followed by the Baltic and then the Mediterranean, which means that all semi-enclosed seas suffer from the same problem, okay? But considering the size, of course, the Mediterranean is the largest marine basin and has the largest coastline, population around the coast, and so forth. With respect to sea level and salinity, a few words. This is the mean sea level for the Mediterranean. I'm not going to steal the discussion of tomorrow's and the day after's panel, so I'm just going to show you one figure. We have, from this analysis, a trend plus 3.6 millimeters per year, and some scientists believe that the eastern part of the basin is more affected by this sea level rise than the average basin. The salt, as we have increased heat, we have increased evaporation, and apparently salt goes up, so salt concentration, at least in this analysis for the 300 upper meters of the Mediterranean in the last, 25, 30 years, is a continuous increase. This is the analysis that we have done in situ in the buoys offshore Crete at HCMR Poseidon buoys, and from continuous cruises over the area, we cover a time span of almost 40 years, 35 years, and you can see that from direct measurements with CTD casts, as they say, we have an increase in these warm colors which show higher salinity even in a package of 800 meters of water or so, which is again validating what we see in the surface with the analysis of satellite data. With respect to CO2 and pH, I don't have data to show you from the Mediterranean. My colleagues will explain why, so I'm going to show you just an example from the global ocean. This is the CO2 flux going upwards as expected, and this is the pH going down as expected. Okay. Someone might argue that the differences are not very much high, let's say from 8.11 pH, you go down to 8.05. This is very high, okay? It has great impacts on the marine life. And now let's come to the hot, let's say, topic, the biodiversity. Biodiversity is a huge topic, going from microbes to whales. I'm not going to talk about all that. I just got some examples. Overall, we notice that we have an increase of alien species in the Mediterranean. One of the main reasons is the opening of the Suez Canal some decades ago and the passage of species from the Red Sea. Now the warmer Mediterranean water makes it attractive to those species, and also we have species coming from all around the world in terms of ballast water from the big merchant ships. Nevertheless, it is apparent from the distribution, the spatial distribution of the number of alien species that in the Eastern Mediterranean we have more. And I believe that it is evident we have more, not only because we have a lot of marine traffic, but because the environment is warmer and most, let's say, favorable for alien species. This is a nice poster, like, let's say, compilation of several alien species, well known, more or less. I stick to Lagocephalus. We had a small discussion while waiting for the bus, how dangerous it is and how it could be eaten without knowing that. And this is the lionfish, which is a new, let's say, delicacy for the kitchen, but there are several others. Some of them are exploited for edible food, which is not bad, by the way. Some analysis of my colleagues at the Institute of Fisheries say that under climate change we might have a regime shift. And at the end, we might turn in a couple of, I don't know, centuries, where we have now a fish-dominated area, sea, we might have a sea dominated by cephalopods and crustaceans, but are great, but I wouldn't like them to be dominant. Another projection says that the Mediterranean will be sometime a jellyfish soup. We have several examples over the last couple of years with blooms of jellyfish. I don't know if it's going to become, let's say, an everyday phenomenon. Overall, from what I have learned over the years and by discussing with brilliant scientists like you, we have come to the conclusion that the Eastern Mediterranean is a more sensitive sector of the Mediterranean basin as a whole. It is sensitive to pollution, it is sensitive to climate change, and it responds faster to all the problems. Some, let's say, projections for the future. Sea surface temperature, salinity, sea surface height, and evaporation minus precipitation are all increasing, and this, more or less, will result in an increase of the basin's salt content. The sea will become saltier. And also, the SST, until the end of the current century, is expected to increase by 3 degrees, and surface salinity will increase by 1.27 in the Levantine and 1.3 in the Aegean. These are very huge figures, regardless of what you see is a small number. At the end of the century, there is a projection that sea level will increase by more than 1 meter. You can imagine what will be the consequences. Now, altogether, salinity and temperature counteract, and at the end, they create heavy stratification, which means there is a blockage of oxygenation and exchange of water between the surface of the sea and the deeper waters. And this will cause what is named weakening of the thermo-aligned circulation. So the whole way that the water bodies move around the Mediterranean might change. It's not only the Gulf Stream that some projections say that it will slow down or stop. The same, to some extent, will happen in the Mediterranean circulation, which, if you can recall, is an anti-clockwise circulation from the west to the east. We are not completely sure what will be the combined effects, but believe me, we do know that they're going to be negative. The alien species are going to increase, the number is expected to increase. The carbon cycle will be disrupted in many ways. We don't know all the details. As I said, we are talking about organisms from the microbial loop to invertebrates. We have expectations of reduced oxygenation, which is a huge problem for marine life. And of course, all this reflects to people. We're going to have societal pressures, economical pressures, and a lot of trouble along the coastal zone, which more or less involves the majority of economy. With respect to policy response, there are some scenarios from the IPCC. Just to refresh your memory, this is the representative concentration pathway, RCP 8.5, which means more or less that we are doing nothing, the business as usual scenario, which means that at the end of the century, we're going to have a CO2 equivalent as the one we had 55 million years ago in the Paleocene-Eocene boundary, which is, I don't know, I cannot even name what it is. If we follow some regulations and we do some sincere efforts to, let's say, ameliorate the situation, we're going to have one of those three scenarios. This is the most green, the medium, and another one, the RCP6, which again has higher CO2 concentrations, but maybe they are, let's say, easier to adapt to. All this, of course, reflects the temperature, and according to the different scenarios, you can see we can have an increase of temperature up to from 2 degrees to 5 degrees, but this is a global estimate, so you can imagine what will happen here in Cyprus, in Greece, and other countries. So, to put it all together, we are experiencing what is named the triple planetary crisis. It's not only biodiversity loss, human pressure, many anthropogenic activities, and pollution. On top, you have an umbrella, which is the climate change, and makes everything worse. There have been some international frameworks. We also already talked about the Paris Agreement. We have the United Nations Sustainable Development Goals, and number 13, which focuses on mitigation and adaptation, is a call to climate action, okay, to mobilize funding, to build resilience, integrate measurements into national policies. We have the decade of the ocean. the United Nations Decade of the Ocean Science for Sustainable Development, where the message is the science we need for the ocean we want. I think that to some extent we have the science, at least the science, to identify the problem and put it in a correct framework. Now we have to stress our effort on how to resolve the problems, how to create mitigation, and more adaptation strategies to adapt to climate change. Recently in Nice, I was very glad to be there. We enjoyed the United Nations Ocean Conference. I remind you that several countries have submitted the commitment, which amounts billions of euros to the salvation of the ocean. I'm not very confident that this is working that way, but in any case, I can realize that there is a good motivation from many countries to offer towards, let's say, the savior of the ocean. And from the Greek side, okay, we are not as big as Italy or France or Germany, but at the European level, we have Climpact, which is the national network for climate change, which has been operational for the past 6 years or so. And this is an effort to join the academic and research communities in Greece. It has been successful so far. I think there's going to be a presentation the other day by Professor Michalopoulos. And with this, I will stop here, and I thank you very much for your attention.
Thank you, Professor Karageorgis, for this insightful lecture on the challenges facing the Mediterranean hotspot. We now transition to the panel discussion, where we will explore strategies for mitigation and adaptation on this critical topic. I invite Professor Kostas Papanikolas back to the podium, who will serve as the convener for this discussion.
May we have the lights back somehow? Okay, we are moving to the second part. I would invite our panelists and the speaker to join the panel. The way we agreed we'll conduct this is as follows. We'll have 2 rounds of presentations, very short, from the first by Mike and Zvi. I asked them to select 1, maximum 2 points out of Ari's presentation that they will say, oh, pay attention to this, okay? So these are world experts. They will tell us which one keeps them non-sleeping at night, okay? And then, the second round, each one, including Aris, will have to identify 1 measure. I don't want 2, I don't want 20, 1 from each, that they say, if you are going to put any effort, this should be the area what you should try to adapt. And they should take into consideration not only the risk, but also the feasibility of the measure, something that is doable, and the realities of the region. So let's go. So I'll ask first, Mike, tell us what I have 2 points you singled out from Ari's. So they came prepared. These are not new questions. So
this is it.
So you already have it on.
Yes, in fact, thank you very much. And can I say how pleased I am to get the opportunity of visiting your wonderful island in the Eastern Mediterranean. It's my first time. I'm going to follow up on a comment your president made, which is the contrast between the science and the politics, and really talking about, really the headline is the worse climate gets, the more we seem to ignore it. There's no shortage of information, which I don't have time to go to, that we're all heading in the wrong direction, whether that's climate, biodiversity, resources. And in my organization, EASAC, we tried to bring that together in a report earlier, which may be available. I'm not sure. So I'll briefly talk about some of those aspects. We talk about biodiversity and climate change and all, but there are in fact 9 planetary boundaries within which we should be operating if we wanted a sustainable planet and a sustainable civilization. And as you see by this, 7 of those 9 have been exceeded, and some by a very large margin. In this report, we looked at all the indicators of the various planetary signals to greenhouse gas emissions, resource productivity, planetary boundaries, global temperature, and we found they're all going in the wrong direction. And worse still, some of them are actually going in the wrong direction faster. For instance, CO2 last year rose in the atmosphere 3.3 ppm. It's never done that before. So what are we looking at? We're looking at updates. We've had 2 recently, which show that while we've been making very good progress on things like solar and wind, it's been offset or hampered by a lack of progress in so many other areas, such as we're still burning far too much coal, we're burning forests just to make electricity, we've got lots of wildfires, wars are creating quite a lot of more emissions than they used to, and the result is that this 1.5 target that was mentioned earlier has already been overshot 2 years running. The latest scientific production says we are hurtling towards climate chaos and the planet's vital signs are flashing red. Well, I think it's difficult to disagree with that. We're also facing the passing of various tipping points, whether that's Amazonian forest breakdown, leakage of methane from the forests and melting of the Antarctic and Greenland ice caps. They're all going at a far too fast rate and are in danger of plunging us into an irreversible and uninhabitable world. Aris showed you the big variety of future forecasts depending on what we do. As you can see, there's a huge difference between the lower levels, which are already being overshot, and the potential huge temperature rises and sea level rises that stand in our future if we don't control things better. So that is a rather negative assessment of where we are. What does politics do? It's going in the opposite direction. Trump has already been mentioned. Trump is an outlier by anyone's definition, but unfortunately he's a very powerful outlier. But even in my country, you've got shifts in political policies from the long-term to short-term expediency, and that has also spread into the European Union after the last parliamentary elections with more populist members. So we looked in this, are we ever going to be able to fix this? Or is there something in our system which dooms us to this bleak future? And our conclusion was that there's a lot of evidence that in fact we are doomed if we don't change the system, because we're giving rewards to all the wrong things. The special interests, the oil and gas and coal industries are so effective at avoiding any restrictions by political means, by scientific sabotage, and our economic system is still rewarding all the wrong things, and trying to get politicians to actually face that head and introduce the necessary reforms is proving very difficult. Our last commission, with its Green Deal following the COVID elect, actually had quite a long list of positive moves, and they're in the green here. I don't have time to go through them. But if those are all being diluted or delayed or combated in the current climate. And so when you're thinking about what can we do as individuals, the only thing you can say is that your own individual activities are only going to have a very small effect, but it is important to support the political forces that actually are trying to move in the right direction. And that's all I have time to say, so that would be my single message. Thank you.
Thanks. I just like to have a few comments. First of all, I would like to congratulate Professor Papanikolaou for initiating this project. I think what we are facing in the Eastern Mediterranean, in order to deal with this, we need communication between the neighboring countries. And this is a good example of what is being done. The Eastern Mediterranean is very unique, and we heard about this from your lecture, and it's very important for very many aspects. Water desalination, marine agriculture, mines, etc. And what's going on today is not very good. And in order to deal with it, first of all, we need to know what's going on. And therefore, we need to observe the changes along the coast, but also in the deep ocean. This is very expensive to do. We try to do it in Israel, putting a buoy down to 2 kilometers and very parameter. I discussed with Professor Papanikolaou before the possibility of putting other system like this. It's very expensive, and it's not very simple, but we need to do it. There are other aspects in this basin beside the rising temperature. For example, it is very polluted. Just to give you a number, the Eastern Mediterranean is much less than 0.5% of the world ocean. Yet, 15% of the tankers moving with oil moving here cause pollution. It is not as simple. And when I hear in the news that Israel increasing the exploration for gas and oil, it makes me very sad. It's also going on with other countries. I don't know how we can fight this. Just to give you, to understand what I'm saying. You remember more than 10 years ago, the BP disaster in the Gulf of Mexico. You remember this probably. It turned out that the Eastern Mediterranean side is exactly like the Gulf of Mexico. But what are the three main differences between the two? In the Gulf of Mexico, the coasts are relatively smooth. In the Eastern Mediterranean, you have the Black Sea, the Marmara Sea, the Adriatic Sea. Another major difference, the connection between the Gulf of Mexico and the Atlantic Ocean is going through the Florida Channel, several kilometers deep. You know what is the average depth of the Strait of Sicily? It's between 100 and 200 meters. It means that if we will have a disaster like oil spill, if we will not deal together with it, it will stay for generations. And if there is oil spill, okay, and another thing, very important, that all the countries around the Gulf of Mexico speak with each other. Unfortunately, it's not the same situation here. So, for example, if an oil spill happens off Israel and it flows to Lebanon, how do we deal with it? Certain instrumentation. All these factors are in addition to the increasing temperature. And apparently, I don't know, the power, we tried the Israel Academy to talk with the government. It doesn't help very much to reduce emission. It doesn't help. But anyway, I think this is a very important forum here and I congratulate you for initiating this. Thank you.
So it's clear from both of you, the single point you selected out of Ari's talk is all of it. So now I'll insist though on the second round, where all three of you, before we open the discussion, you'll have to select one measure that will propose, let's say, to the governments of the region, say, A, if you're going to do something, get together and address this point. So, Ari, you go first.
If I were to choose just one, I would choose something almost similar to what Asvi said, ocean observation. You see that in many cases we have data, but the data that we have refer to the upper part of the ocean only. We don't know what's going on below. And it's a very expensive, let's say, exercise, but there's no other way. We need to know what are the actual consequences and impacts. We know what is going on in terms of the variability of physical parameters, but we don't know well enough the impact to the biology. So I would go on for a network of measuring stations end-to-end, from physical parameters to biology.
So basically, if I, since I'm the non-expert here, let me see if I understand it. You don't have enough data as you would like to have, therefore you need observations. Like a very good scientist, you think it's expensive, which is not, compared to the size of the catastrophes that are pending. This is the usual problem with scientists. And this you need in order to forecast, modeling, and all that to see the other parameters, correct? I understand it correctly? Okay, we need more observation, more modeling, presumably, to refine the projections before we go into, okay, I'm very glad to hear that, because in our recommendations, not only for the sea overall, the observations and modeling, we say it's a must. Okay? Now, Zvi, and I'll go in the reverse. One, you can choose the same, but you lose your chance to add another one.
The trend, apparently it seems that the only solution for the temperature rise is moving to nuclear energy. And many countries started doing it, like in Japan and Saudi Arabia. We look on this in Israel, etc., because if we leave the situation as such, we saw in the diagram, completely catastrophe. And I think our duty as scientists is to go to our own government and to try to convince them.
Okay, more renewable, not only nuclear, presumably, right? I happen to be a nuclear physicist by profession, so I have an opinion on that. But one of the problems there, to build a sizable nuclear plant today, not on the books, but what it takes is something like 15 years. And there is not capacity to build many nuclear plants. The know-how is not there. So time, even if you could produce all these nuclear plants, just ain't there, the capacity and the know-how to move fast enough. So as a scientist now, who follows this field, it has to be there, but it will be a part of a basket of solutions, along with wind, solar, hydro, etc. But certainly, your point is well taken, because still there is some apprehension from old days that nuclear is dirty, as some of the Americans say. Nuclear is not the solution. No, it is. It's part of the solution. So even for oceans, and you're an expert there, you see we have to address the primary cause, CO2 emissions. That's really your message. When it comes to sea, though, a mitigation or adaptation measure directly on the sea, what would you say? Not on going to the deeper cause. Because what you are proposing is mitigation, really, is not adaptation. You have from, if we stay...
One of the problems worldwide...
Closer. Microphone.
That, people at the top do, almost in every country, do not look at the long range. Everybody wants to see that when he is in power, something happens. We bought big money, big this, and it's very difficult to say. We are working on this, but it's not simple.
Okay. Mike.
Well, it's a long way from measuring deep ocean to global nuclear strategy, but we seem to have done it in about 30 seconds. I'm going to go back to the Eastern Mediterranean. Of course, everyone wants more research and everyone can benefit, but the basic problem at the moment is that scientific knowledge and objective analysis is being undermined by both like the growth in social media, opinions, being given equal status to careful peer-reviewed papers, and the ability of the political, or the tendency of politics to be increasingly short-term oriented. And so that when the scientific message is that we need to do things now to achieve results in 20, 30, 40 years' time, or even to safeguard our children and grandchildren, that message no longer has the impact it had 10, 20 years ago. Everything's now so far short-term. We've always talked that the democracies with their 3 to 5 year legislative election period almost build in short-termisms, but we've got to the markets also driving companies for a 3-month period now of performance, not even a 6-month or a year. And that is driving this short-term pressure to actually just guarantee the short-term benefits and to hell with the future and let the future take care of itself. There isn't an easy strategy against that, but one has got to try and strengthen the impact of objective analyses, scientific analyses, environmental analyses on the political process. And that puts a heavier burden on organizations such as academies, on communication strategies of individual scientists. We've recognized that for many years, but this is becoming even more urgent. And it requires the public as a whole to recognize and use it in their voting preferences, that they want to know what's really going on. They want to have trustworthy information, and they want to think about the future. And they can't just rely on what they've just read on X or Truth Social, certainly not Truth Social, and all that. There has to be a great, much better effort to get objective analysis back into the political discussion and to try and pressure and reward scientists and politicians who are prepared to take a longer-term view on the future of their country and of their population. So I would say it's more the big challenge at the moment is information and how to manage it, how to communicate it.
Okay, thank you. So, big problem, no easy way. Okay. Now we'll open the discussion to each one of you. Please raise your hands if you have. I would prefer first to gather questions, and if you want to make a statement, make it very brief because of time and efficiency. So, any questions, comments?
Thank you for a very simple and understandable talk, Professor Karageorgis. Now, is it not the case that if tomorrow morning we stop emitting any CO2, the accumulated CO2 up there will remain for several hundred years. And therefore, whatever we do, the problem will really get worse. So if I were somebody to prioritize research, if research is a priority these days, which regrettably is not in big decision-making countries, CO2 capture is probably the #1 area where we need to focus, because the problem will continue to get worse no matter what we do, whether we're going nuclear, whether we go completely solar, or no matter what. Do you share this view?
I do agree that carbon storage is a part of the solution. There have been some very promising experiments. And actually nowadays there's been a big European Union-funded project in northern Greece where they are testing carbon storage in the old drill holes of Prinos in Thassos. It is a promising technique. We still have to look into it, but in general, if we can call it in a more generic term as geoengineering, I would not go against. It is something that looks promising. I would go for it.
Yeah, but there are other techniques, microorganisms in the oceans is an idea.
It's worth exploring that at a scale that can be applicable to solve the problem, because now we are still at an experimental level. I don't know how fast it can grow. As Costa said earlier, it takes 15 years to make a nuclear reactor. I don't know how many years it takes to make a factory to store CO2, but nevertheless, it is a solution that has an end, because CO2 will be stored. Now, the consequences, the side effects, the earthquakes, I don't know how this is going to work. We don't know much about it. We hope that it is going to be applicable.
There are some technically possible ways of removing CO2 from the atmosphere, but there's 40 gigatons of CO2 going into the atmosphere every year, and the cost of reducing those emissions are all in the either beneficial but not done, or in the $10 to $20 per ton of CO2 capacity. The cheapest effective way of removing CO2 from the atmosphere is in the hundreds of dollars per ton of CO2 removed. So too many people are using this, particularly the oil industry, as an excuse for not reducing their current emissions, whereas it's economic nonsense to suggest that you're going to be able to remove so much that you can actually offset the huge amounts being produced. But the problem is that in the IPCC models, they've had to try and identify a pathway to actually stop catastrophic global warming. And the only way they can use it in the models is to invent a mystery technology which can somehow remove 10 gigatons of carbon from the atmosphere a year. And that has led people into what I regard as a total wild goose chase, looking for this mystery technology which is in the IPCC models. And the one that they've mentioned most is this thing called BECCS, which is bioenergy and carbon capture. And that requires you to be burning fuel, trees or crop, and then capturing the CO2 after you've burnt it, but using the energy. And that sounds okay on principle, but we've looked at it in very great detail. And there is no way this will ever lead to a net reduction in the atmosphere. All it might do is actually reduce the rate at which the atmosphere is increasing. And so again, these are almost like holy grails that are there to try and be used by particularly special interests to offset their responsibility to actually reduce their current emissions. So I'm afraid it is no silver bullet and not likely to make any significant contribution.
Yeah, I totally agree with Mike. I would say it even more bluntly, the oil companies love it. They say, okay, we took it out, and they will use arguments like you say, we have this drilling that are either Prinos or in Saudi Arabia or whatever, and we'll capture it and put it back in. We'll be the experts. So it's greenwashing by the oil companies. The technology doesn't exist, or what exists is non-affordable. Mike gave the numbers. So, and I'll add to it, I'm not repeating, I repeat it now, I'll say, just to give you how bad the situation is, I'll make it addressing what we saw from Aristotle. If we continue melting ice and warming at today's rate with the CO2 there, the sea level rise at the end of the century will exceed 1 meter. I gave this about, I think Sula remembers it, I gave this maybe 12 years ago, this same line to a meeting of the tourist industry here. I say, what if you are, at that time I thought it was 50 centimeters. I said, what if you have sea level rise at 50 centimeters? How many of your beaches will stay there, or it will move up to, you know, will become like Venetia in Mykonos. You will be next to your balcony. They turn pale. I said, is it really a possibility? It's going to happen. And even if we start capturing, this is one, and this is connected to this talk, it's one event that is non-reversible, unless the oil companies tell us they're going to make ice machines to put the ice back to the Greenland and Antarctica. This is non-reversible. Even if we remove the CO2 immediately, the water will not go back, will not become ice. It will take thousands, probably tens of thousands or hundreds of thousands of years to put the ice back where it originated. So a lot of things are going to happen, even if there was such a machine, which there isn't, to effectively capture the CO2. Yes, there is a question back there.
Thank you for the nice talks. I have a question about how wild is the idea to try and put sulfur up into the atmosphere to try cool the planet? Like I read that one group in Harvard was, so how wild is this as an idea?
So geoengineering, who wants to answer that?
I think you're talking about stratospheric injection of sulfur dioxide. I mean, there is some scientific basis for that, because one of the reasons the planet is warming a bit faster than originally predicted is because we have cleaned up the emissions from shipping, which were emitting a lot of sulfur, and that was actually creating these aerosols, which actually did have a slightly cooling and dimming effect. So in theory, you'd be repeating what happened after some volcanic eruptions, such as from Pinatoa 150 years ago, where there was a planetary cooling of half a degree or so after a huge ingestion. So it does in theory work, but you don't know what the regional climate effects are going to be. Certainly the Pinatubo eruption caused mass famines in Europe and such, and the question is, do we want to encourage even more mass famines than we have at the moment by this sort of thing, because it'll affect weather patterns, rainfall patterns as well. And the other thing is that who is going to do it? Are we going to, if we can't get an international convention agreed on reducing our climate destruction, how are we going to get an international convention and an international resource of equipment to do this? It could be that one country decides to do it, but that might be another story. So again, it's what I regard as, in English, it's the drowning man clutches at straws. In other words, if you're in a really desperate situation, you look for any excuse or any way to ignore your current situation. And I would class it along with that. There is an interesting proposal, more regional, to restate the Arctic ice by having fleets of ships which are injecting seawater aerosols, and that volatilizes and gets salt particles into the atmosphere, which causes clouding. And if you do that during the summer to stop the ice melting, it'll build up during the winter. And that's an interesting version of this atmospheric injection approach.
Just to add here, Mike and colleagues, that sometimes the policies counteract. In fact, the policies in the European Union in the last 40 years or so to reduce particle emissions from factories has been effective, and it has shown that clearly there is a reduction of particles in the atmosphere, and this is good for the human health and so forth. But at the same time, the particles that are good for the health, if they are not there, they are bad for the climate, because if they are not there, there is more absorption of heat. The particles act as little mirrors and they reflect the irradiation back to the atmosphere. So there is no direct solution to that problem, at least unless we find the mystery that Mike mentioned, the mystery science that will resolve the problem. And of course, mysteries do not exist, so I think that we should talk about the basket, okay? The basket of small solutions. It's not one solution. It's going to be many of them.
On the geoengineering, since we have the experts here, I have a question related to it. If you do this geoengineering, so you reduce solar radiation, this will not reduce CO2. On the contrary, it will encourage more CO2. Now, a lot of the effects you show on the ocean come by the acidification, which presumably will continue because this will not be reduced. Refining the question, assuming that you solve the temperature rise, because that you'll shield with this blanket up in the stratosphere, but CO2 will keep increasing. That's the implication of geoengineering. How bad is this for the oceans?
As far as it concerns the continuous increase of CO2 uptake, the effect is going to be accumulating. There's no way back.
No, but which effects will continue? Because this solution, which is not usually said in the same article, reduces solar radiation and increases CO2 by implication. Now, in this scenario, how do the oceans respond? Less heat, more CO2.
I guess that at the beginning there's going to be an increase of CO2 uptake, and then there's going to be an equilibrium. But this is just a wild guess.
Zvi, do you want to comment on any of this?
Nothing much to add on what they already say. There are many ways to go, many solutions. There is not one miracle way to do it. And we have to try various ways. For example, just an example that popped into my mind, in the Eastern Mediterranean, we have big resources of gas hydrate. I don't know if people know what is gas hydrate. This is a clean energy, but it's a bit more expensive to explore. In my mind, we have to go to, for example, to try to explore gas hydrate rather than drilling for fossil gas. And batteries, etc. No miracle here.
Okay. Any other comment? Yes, Marco.
Thank you very much. I'm a biologist from the area of infectious disease biology. And when I was hearing,
A little bit louder.
when I was hearing Ari's presentation, I was thinking of in the world of microbes, increased temperatures usually translate into faster reproduction, and faster reproduction when it comes to pathogens, it usually translates to increased pathogenicity, but also into increased diversity, which can bring the appearance of more pathogenic microbe strains. Now, this is something that happens on terrestrial environments continuously, and not only for humans, but also we're experiencing a mass extinction of frogs, for example, that is caused by microbes linked to climate change. But I can imagine that in marine environments, this could be much worse, because in terrestrial environments, at least the microbes don't usually jump from one place to another by themselves. In marine environments, you have the water that helps them move around, and also the acidification is probably reducing the capacity for some of those organisms to defend themselves. So my question is has there been cases like this in the Eastern Mediterranean, and is somebody monitoring this? Is any organization or organism keeping track of the potential effects on pathogenicity on microbes?
Okay, thank you. This is a nice question. We have been dealing with this question within CleanPact. The last 3 years, we had the panels on human health and climate change, not particularly related to the sea, but also to the atmosphere. Indeed, there is increase of pathogen and diseases which are airborne, and this is a fact for the land environment, the terrestrial environment. As far as it concerns the sea, I will give you an analog. If you go in a hydrothermal vent, which is a warm environment on the seabed, you will find extremely increased biodiversity, which means indeed that there are many organisms. Some of them are archaea that are very rare, and they exist only in those isolated environments. I cannot imagine what will go on if this is a global phenomenon. It will certainly create new types of life. What would resolve this kind of, let's say, issue would be to not something, let's say, very spectacular. You need an eDNA monitoring continuously, which is something at the beginning, but it is feasible. So you start to monitor it by diversity, not by measuring the species one by taxonomy, but by the variability of the DNA structure. So you can really do that. But I think it's very direct that an increase in the temperature overall will increase the microbial activity and maybe increase the diversity, as it happens in some hotspots around the ocean.
Okay, 2 more questions, and I'll encourage their experts in the audience on these subjects if they want to offer an opinion.
Thank you for the wonderful presentations. I really enjoyed them all, and excellent discussion. There are many things to say here, but I will try to be very brief. The solution is certainly several solutions if it's not too late already. One of them is to reduce the CO2 emission. And here I have a comment. We always see scientists from Europe talking about climate change. Where are the scientists? You are in the field, so you probably know. Where are the American scientists? Where are the Chinese, the Indian scientists, the Japanese? We rarely hear someone talking about it. The solution could be several things. There was this crazy idea several decades ago is to plant fast-growing trees and dump them in Antarctica, store them in Antarctica to trap CO2. My question is for you, since the majority of the CO2 or a large quantity of CO2 get dissolved in the ocean, do we know if this ocean will get saturated at some level? And then if it's so, what will happen?
Okay, that's one question. Before we answer, let's collect if there is one more, and then we'll close it. There is any other questions? No? I think you all know there is wine outside, and maybe we should stop. So let's answer this question, and we can discuss the rest with some wine. Okay.
Okay, Kostas, the expert is Abed, and Abed is at the hotel. He just arrived when we were leaving with the bus. so he's the most suitable to answer. What I can tell you briefly is that, of course, in every chemical system there is an equilibrium state, but we don't have enough information to tell you when this is going to happen exactly, because particularly for CO2, the pH, alkalinity, and so forth, there is very little known, and modeling is very poor. We need to work hardly on that to make, let's say, a model that will make safe predictions. And this goes for all the modeling. What we have said today and all the projections are made based on models. One of the side effects is that all the models show high uncertainty. We know the trend, more or less, that it's going to be for the worse, but when we are talking about measures and what is the value of each measure in extracting CO2 from the atmosphere or reducing the effect of temperature, then we have a large degree of uncertainty. And this is, I think, the message to the scientific community, to try to work hard on each individual component of the modeling systems to improve the uncertainty. And this is going to make our predictions more robust. And then the politicians will, let's say, believe us more. There is still a lot of skepticism in the political level that what we say is not, let's say, useful for making policy regulations. I think this is something that we can all work on, and this could be a contribution at the basic knowledge that the society needs.
Well, the ocean has a very important point in mitigating the emissions. It's absorbing about 26% of the emissions emitted. My impression was that it was assumed that as the temperature rose, its effectiveness at removing carbon would decline. That may not just be the chemistry at the surface, but it also may be a reduction in the deep water formation, which actually is the ultimate repository for the CO2 absorbed on the surface, gets biologically converted, and some of that gets down into the deep water through ocean currents. And of course, we're worried about the decline of the Atlantic meridional overturning circulation, or AMOC. And of course, if that goes off, then you've got stratification, which would impede those removals. But as Aris said, it's high uncertainty, and I think we can assume it's not beneficial.
Okay, I think we should wrap it up. I don't know if any of you want to make any concluding statements. Yes? No? Okay. So thank you very much. I hope hope we can continue discussing this outside. Thank you.